Dear students, in the last unit, that is unit number 1, we learnt about various objectives of statistics, the importance of statistics, advantages in statistics, at the same time disadvantages of statistics. In the last topic, we learnt about various sources of primary and secondary data, and now we are going to discuss about the second unit. The name of the unit is Measures of Central Tendency, comes under chapter 1, and the second chapter is Measures of Dispersion. What is central tendency? Central tendency can be described in one word as a single value that is used to define a set of data by classifying the central position with the set of data. Particularly, if you observe, this is the reason the measures of central tendency are also known as measures of central location. It is also categorized as a summary of statistics. That means central tendency, we come across number of topics. Particularly, we learn about averages, the qualities of a good average, and at the same time various types of averages in this topic. Let us move on to objectives of central tendency. The objectives of my central tendency is to present a brief picture of the data. That means it gives a brief description about the main feature of the total entire data. Second one helps in decision making. It helps in decision making by planning and developing business economy. Third one, it acts as a representative of the group. That means an average represents all features of a group, hence the results about the whole group can be derived from that particular derived value. Next one is brief description. An average gives simple and brief description of the main features of the whole data. We need not study the entire data, but by studying the brief description itself, we can know about the entire data. Next, helpful in comparison. Measures of central tendency reduce the data to a single value. That means average, arithmetic mean, like arithmetic mean, median, mode, which has a single value for comparative study. The comparative study thereby helps in further development of an organization. Next one, helpful in formulation of policies. Particularly for a developing country like India, most of the policies formulated are taken from the statistical data previously. Therefore, averages helps to develop a business in case of a firm or help the economy of a country to in developing stage. Last one, base of other statistical analysis. By deriving these objectives, by deriving the statistical values, one can find the base for the averages, particularly like mean deviation, coefficient of variation, correlation, analysis of time series, etc. help us in particularly based on averages. Next, coming to the second topic, dispersion. Dispersion is the extent to which a distribution is stretched or squeezed. That means if a data goes on in a parallel way, suddenly if it deviates at a particular place, that particular place is called as dispersion. In short form, it is nothing but a deviation. That means from one location at a place where it shifts to another location, it is termed as dispersion. Statistics is a discipline that concerns particularly with the collection, organization, analysis, interpretation and presentation of data. Particularly, there are two statistical methods. One we have already learned with the name measures of central tendency, and the second one is measures of dispersion. Here, the dispersion we can come across. Dispersion is a measure of variation of items. Dispersion is a measure of extent to which the individual items vary. Dispersion is the degree of scatter or variation of the variables about a central value. Particularly, dispersion means nothing but the place where the entire distribution is deviated, stretched, squeezed, scattered. All these terms comes under dispersion. Then coming to objectives of dispersion, almost all the objectives of dispersion will be same as the objectives of central tendency. These two are different measures, but their objectives are one and the same. Here, number one is comparative study. Measures of dispersion gives a single value. Likewise, in central tendency, we have already discussed in central tendency that the averages gives a single value. The degree of consistency or uniformity of the distribution. This single value particularly helps in making comparison of various distributions. The smaller the value of dispersion, higher is the consistency or uniformity, and vice versa. Particularly, reliability of an average. Precisely, we can say that these measures of dispersion are more reliable compared to measures of central tendency. Here, a small observation or small deviation will show us a better analysis. It means that the average is a good representative of observation and very much reliable. A higher value of dispersion means greater deviation, and at the same time, a smaller value of dispersion means a small deviation. In this case, the average is not a good representative. It cannot be considered reliable. When compared to central tendency, the dispersion is comparatively more reliable. Next, coming to third point, control the variability. Different measures generally provide dispersion as data of variability. Most of the people say dispersion is nothing but a data of variability from different angles, and this knowledge will definitely prove helpful in controlling the variation. That means wherever we find the deviation, wherever we find the reason for the deviation, we can take necessary steps in controlling that deviation, and we can stop in future about the stoppage of deviations. Especially particularly in financial analysis of business, these measures of dispersion are very much useful. All the tools are very much useful. Both central tendency and dispersion are good enough. But when situations arises, different organizations will take into consider different statistical tools. Finally, it is the basis for further statistical analysis. Measures of dispersion provides particularly the basis for further statistical analysis like computing correlation, regression, test of hypothesis, etc. Next, coming to the qualities of a good average. The averages are, we already discussed in measures of central tendency, and in the next topic we will discuss different types of averages. Before going to discuss different types of averages, let us now discuss what are the qualities of a good average. Number one, it must be simple. That means the average calculation of average must be very simple. That means the fundamental feature of an average is that it should easily be calculated and simple to be followed. Second one is representation. That means while computing the average, the entire data must be taken into consideration. Total data. That means the average must and should represent the entire mass of data. Third one, the average must be rigidly defined. That means the average, there should be no deviation in the average calculated by one person with the other. That means there should be a definite figure that will get by each and every person who compute that particular average. Next one, further algebraic treatment. That means with that average you can further calculate some more averages based on that average. For example, for computing standard deviation we need arithmetic mean. Likewise, for mean deviation we need mean and also median. Likewise, many averages are based on further algebraic treatment. Clear and stable. That means the average computed must be very clear and must be stable. That means even different persons calculate with the same data must get the same solution, same treatment. That is the clear and definition. Absolute number. There should not be a vagueness in the answer. That means absolute number must be represented. The average should be exact. It should not be vague. We should not say that the average between 20 to 30. No. We have to say exactly as 23.52, 26.52. Likewise. That means the average must be exact, clear, absolute. Next one. Effect of fluctuations of sampling. That means a good average should not be affected by fluctuations of sampling. That means if a new sample is taken, the fluctuations must not be very much wider, very much deviated. That we have to understand. In other words, different samples, if different samples are taken, that means all the sample should represent an equal and exact answer. Next one, not affected by skewness. A good average is one which is not affected by skewness in the distribution. Skewness means unsymmetric. This we call symmetric means it follows a particular line. Asymmetric, we call it as asymmetric. Asymmetric means it will not follow a particular line. That means skewness should not affect anything on the average. That is important. Particularly skewness will be calculated based on these averages and it will be explained in future topics. Next one, based on all values of variables. That means each and every variable must come under the calculation. We should not leave any one of the variable and every variable should take into consideration. However, few averages, but particularly what we are going to discuss in the next topic, will not come under a good quality of good average. Why? Because they, in some particular in calculating mode, in calculating median, some part of the data will be ignored. We find the median class or mode class and that the end of the taking the other data and we consider only that particular class, previous or next classes itself. That is a serious disadvantage. When we discuss them, we will explain. I will explain you. No effect on extreme values. For a good average, it should not be unduly affected by extreme. That means the open end values. It should not be merely or affect more, particularly based on extreme values. Then coming to the different types of averages here. First one is arithmetic mean. Different averages we have. First one is mean. In mean we have three types of averages. One is arithmetic mean, two is harmonic mean, and the third one is geometric mean. See, what is arithmetic mean? It is the most commonly used measure and also called as average. This is the simplest form that even a slightest knowledge of a mathematical operations is enough in computing average. In simple, it involves how to calculate. In simple, we can say the total sum of group of numbers divided by count of the numbers in the given series. We simply take it as sigma x by n. X represents, sigma represents total, x represents the given values, the total of values divided by number of values is the simplest way, the formula for computing arithmetic mean. Coming to geometric mean, here we take into consideration the logarithms particularly. The geometric mean is also an average used to determine performance results of an investment profile. Particularly, investors particularly take into consideration the geometric mean. How much we have invested, how much yield we got them. It is technically defined as the root product of n numbers, nth root product of n numbers. The geometric mean must be used when working with percentages which are derived from values with the standard arithmetic mean works with the values themselves. Same, it is also comes under arithmetic mean. One of the thing is geometric mean. Next, harmonic mean is here you have to underline the word reciprocal of the average. Reciprocal means nothing but 1 by x, 1 by value is called reciprocal. Reciprocal of the average of the reciprocal of the data values. It is based on all observations and is rigidly defined. That means this also comes under good average category. In good average, we already essentials or qualities of a good average, we come across the word as it should be rigidly defined. Harmonic gives less weightage to the large values and larger weightage to the small values to balance the values correctly. That means it will not give even weightage to all the values. The larger weightage will be given to smaller values and a less weightage will be given larger values. In general, harmonic mean is particularly used for where there is necessary to give greater weight to smaller items. It is applied particularly in case of times and average rates. Coming to next, this is called average. Different types of averages we came across: geometric mean, arithmetic mean and harmonic mean. In this topic particularly, this is the end of Unit 2. We will discuss in the next topic, Unit 3. Thank you.